I would guess. Maybe they actually defy gravity, like that one experiment else on. There was also some like,
Yes.
Oh, yesterday morning?
No,
Last night.
Try to recreate that. Hate to say it. That's a tough one.
Okay, we're
We're
ready
ready to go whenever you're ready.
Okay, great. Let's get started. Welcome to our weather discussion for the day. Can't start it off without celebrating this beautiful weather we've recently had. So Pete's got a whole bunch of different views from the rooftop cameras, and you can see this is from yesterday. Just beautiful weather we've had recently, and yesterday was filled with a lot of contrails in the sky. They seem to hang around about, huh?
That's actually today was the
Well, that was today.
Yesterday was the gravity waves.
Yeah, and the sort of alto
Right.
stratus or stratocumulus that was really interesting to look at. Yeah, today was contrails, was the surprise today. And it must be something about the humidity and wind structure at upper and mid-tropospheric levels that kind of allowed them to hang around a little bit longer. I mean, we didn't have more plane flights today than we did yesterday. I'm quite certain of that. It's instead something about what makes them last that gives them the stage today in terms of the clouds. But this is a really cool view, and this is today now, right?
That is
yeah,
today,
28.
that's correct.
So you're looking at the center of this location where the camera's on, that's our building, and then we've got 3 cameras working. The east camera went out, so we're gonna get that fixed. But here you can see not only the images horizontally, but the image vertically on top of it from the satellite. So it's really quite cool to see all of this simultaneously. And that's what the skies kind of look like today. We've had a beautiful stretch of weather. Now I want to just tell you something that I looked up this morning. Last Friday, Saturday, Sunday, and Monday. You remember how warm it was on Friday and Saturday, and even into Sunday. And then we had the clouds invade on Monday, but we still got to 72 degrees. So there was 4 straight days where the high was 72 or higher in late October, ending on the 24th of October. That's only the 3rd time since 1939 that such a streak of 4 or more days has ended as late as the 24th of October with high temperatures of 72 or higher on every one of the days. The other time was when we had the all-time warmest October day of all time, or maybe that's not right, the latest 80-degree day. That was in a stretch in late October 1963. Now, the 23rd of October 63 was the last time we ever saw 80, the latest time we ever saw 80. And then another time occurred more recently, 1989, where the streak ended, I think it was a 5-day streak, ended on the 27th of October. So we haven't seen this kind of late October weather in 33 years. So it's really quite spectacular.
We're turning into a regular Scott Lindstrom.
Yeah, well, it's from the site that he sent me a long time ago. And it's just great to be able to do those kind of things.
Yeah.
So a third of a century has passed since the last time we had this kind of October weather. And we're kind of going into another week where we're going to have days that aren't quite as warm as that, but are still going to be really delightful. In fact, the all-time high for Madison in November, I think, is 78 degrees. I have that written down here. Not on this piece of paper, unfortunately. But 78 degrees on the 1st of November 1944. And then on the 3rd of 1964, it was 77. So we've been well over 70 in early November, a couple of times. But we're not going to get that warm after Monday, but we are going to get into the high 60s, it looks like. Just beautiful weather, just like we've had right now. So it's something to look forward to. So let's start our discussion by looking at...
You want to go to your laptop?
Yeah, the laptop, thanks, Pete. This is my new laptop that Pete's helped me to get organized. This is the whole last week's satellite movie over the continental United States and parts of northern South America and Central America. So you can kind of see, we're in the middle of the week, so when we get back to the beginning, we'll start talking about it. That will be the 24th of October, last Friday. And last Friday, we were, of course, enjoying the beginning of that really remarkable warm streak that we had over those 4 days. And you'll see how it looks in the satellite. So gigantic ridge over the central United States on Friday. There's Rosalind about to make landfall in Mexico. We were preserved from any even high clouds on Saturday, Friday, and Saturday of last week. This is now Thursday, sorry, of last week. No, it is. 24th is last Monday. And then we had a storm come in with some light rain on Monday, when we finally did cool down to something more like Limo, a second event on Wednesday. And then after that one came through, a little anticyclone that sat in on us beginning on Thursday and has really dominated the weather in the eastern part of the United States over the last couple of days. And I want to point out some things about that during the discussion today, because it's really a silent but very interesting weather feature of this week, is that anticyclone that developed beginning about Thursday and then spread over the Great Lakes states in southern and southeastern Canada. So it's been an active week in some parts of the continental U.S., and including our own. We had a little bit of the storminess that was foretold about a week or two in advance of last week's discussion, but not quite as dismal as it seemed in that longer term forecast. It did kind of graze us and give us a little bit of precipitation, but not a terrible amount. How much did Milwaukee get on Wednesday and Thursday? Kalen,
0.6 on Wednesday, and
Yeah, it was
0.2 or so on Thursday.
okay, so I had 0.8 for the total, but I don't think I'd split it up the right way, so that's too bad. So we had one pretty good rainy day, and more rainy in Milwaukee County than it was in Dane County, because we were on the kind of the western periphery of the second stage of that event, which I forget what day that was now, Wednesday, I guess, huh?
Go to Tuesday night.
Tuesday night to
Tuesday
Wednesday.
night it was raining.
Okay, and then over in the Pacific Northwest, it's been a rainy week, and you can see some of the high clouds continuously coming in over that portion of the globe. And in fact, we'll see in a couple of depictions today, I think, a giant anticyclonic wave break that kind of sets up the scenario for this weekend and the early part of next week. Yeah, I was thinking of you, Grant, when I saw it. It's right up your alley. And so, I mean, it's a really great case of that. Although a progressive wave break. So, does it mean that we set up this big block or not? This is kind of a fat ridge that's sitting there, widespread in both longitudinal and latitudinal extent. So, I don't know how it fits in your world, but it's a pretty good one. Okay, so let's take a look. In fact, Pete, can we go to your newly minted Pacific satellite movie for the week? I think we just go back. We can. We're on that page, so we can just pick that one. Yeah, this one here, the North Pacific movie. Yeah, good. And we get rid of this message. Remember last week we had that really intense cyclone that went up into Canada and parts of Alaska, and it left that little disturbance to the south. When we get back to the beginning of this movie, you'll see that thing hung around. That's still it. That thing hung around for several days and actually migrated slightly westward at the beginning of its life cycle. But you can see one after another disturbance coming in here at a sort of a strange angle in the sense that it really implies that the jet is quite strong and kind of zonal, and then occasionally erupts into these big waves. But here's the big break. Look at that. You can even see in the high clouds the anticyclonic turning that's going on there, and we'll see that in PV. So there's our little disturbance that was cut off north of Hawaii, and it lasts for a good long time, gets involved in this next disturbance, which is on the south end of the jet, or the south side, I should say, of the jet, stretched out. Number one that gets stretched out. There's another one that tries to come along the Aleutian chain. That feature tends to get stretched out. There's a little wave break. Again, you can see it turning anticyclonically, but broadly speaking, it just gets stretched. And then here comes the deep trough, and you can see the open cellular convection behind it and the amplitude increase in the waves. But here comes another ridge with a tendency to break off. So it's been a really interesting Pacific week, but not in terms of gigantic late autumn storms or mid-autumn storms. Instead, it's been more anticyclonic in a couple of instances, but nonetheless interesting. Rainy week in Seattle. If it hasn't been organized synoptic systems, it's been the cold air behind it leaves you with thunderstorms and probably hailstones the size of marbles. Just a kind of the beginning of their miserable, cloudy, damp, rainy season, and it looks like it's come in with a vengeance. Okay, that's all I'm going to say about this. Every time I look at these, though, I think about Anita Rapp's talk from a couple of weeks ago. Look at the giant spaces between these convective elements in the ITCZ. A huge area right there in the tropics with almost no convection. And then it blossoms quickly, and then another spot becomes kind of a bald spot. So it's been really interesting. There's another one right here. Look at that. Nothing going on. Really interesting. Okay, we'll see some evidence of perhaps what I don't know if Greg Tripley would agree, but a bit of a disconnect between the extratropics and the tropics. this week over the Pacific, there's good evidence for some reasons for that, if we get to that in the discussion. Okay, so that's an overview from the satellite point of view. Let's start with, now let's take a look at some of our, I guess I have the radar up here. I forget which one, it might be this one, Pete. Yeah, want to look at the national radar across the continental U.S. The main precipitation event is down over Texas and Louisiana. So there's a pretty intense convective blob here. I'm not sure how it's connected to things to the south. We'll look at that in just a second, but that's over the southern coast of Louisiana. And then the feature of a larger extent is over eastern Texas and into the southern part of Oklahoma. And you can see the rotation back here to the west of Dallas. And then a little bit of the precipitation that's come on the Pacific Northwest coast. There's a break behind this band that looks a little bit better organized than some of the open cellular convection that we see on the satellite movie, or that we've seen in the satellite movie over there. Have we looked at can we look at a visible satellite movie, Pete, over the continental U.S.? I like that, yeah, the color visible. So here it is of the current weather, and beautiful clear skies for us. I mean, what a week we've had. Here's the weather system that we're just talking about, and you can see the circulation back there over south of Lubbock, Texas. And then this convective element that we saw nicely in the radar is seemingly separate. I'm sure it's connected in some way, but it's a little bit of an appendage to the east from the main cyclone that's kind of drenching most parts of East Texas and maybe moving into Oklahoma. But it's rather sitting still. It doesn't seem to have very much of a progressive tendency, and we'll take a look at the upper level charts and see if we can't discern why that's the case. Very cold air coming out over the continent and over the shore waters here, and you can see that in the low-level stratocumulus. You can even get an idea of the direction of the wind. I mean, they're just perfectly wind-parallel bands of stratocumulus. Absolutely gorgeous. And the big disturbance is up in the central Labrador Sea, and there's clouds streaming poleward over Greenland on the warm side of this disturbance. That's probably not good for the ice there, as we've heard a lot about over the last few years, the Greenland ice melt. This kind of storm doesn't help that condition. And then a couple of disturbances in far northern Canada. This one here to the northwest of, well, it's in Manitoba, northern Manitoba, north of Manitoba, on the northwest shores of Hudson Bay. That's the center of circulation there, and there's cloudiness associated with that. And you can see it's left some snow in northern Manitoba, Churchill, Manitoba, and places like that. Okay, let's now take a look at the super peats. We'll start at 500 millibars for this morning. So here's our 500 millibar map for this morning. There's the center of the 500 millibar circulation associated with what we just saw on the satellite over Texas. Looks a little further west, of course it's some hours ago, so that feature maybe has migrated a little bit to the east. It's associated with a really intense horizontal baroclinic zone here. Look at this, it's minus 21 degrees at, is that Del Rio, Texas? I can't remember which one. I think that's Del Rio, Texas. Midland, Texas, sorry. So George Bush's hometown, right? So it's minus 21 at Midland, and it's minus 7 in northern Mexico. Really sharp horizontal temperature contrast there. That's a really far south upper frontal baroclinic zone. I did not go back. I think it's tropical where we can draw cross sections. I'm not going to do that today, but that would be a prime place to look and see what the upper frontal structure looks like that far south. I'm guessing those heights, and especially those temperatures, are really anomalous at 500 millibars at that latitude. And so on the eastern side of this upper trough is where we see that whole region of ascending air and cloudiness, and so that's a nice relationship there. We also saw the big storm up over Greenland, and the extended cloud streak that goes all the way from, off the middle Atlantic coast up toward Greenland, and that's tied with this disturbance that's on the western shore of the Labrador Sea. And look at the temperature contrast there. You're minus 28 in this station, Keelan. You know what that station is?
I do not.
Somewhere in Labrador, and then you can get all the way into this warm air where it's like minus 10 or minus 15. So that's a pretty strong temperature contrast at 500 millibars. Remarkable. And then here's the disturbance out over northeast Canada and Alaska, the most recent one. We can't really see the ridge that's coming, but it's there. And there's a very strong horizontal temperature contrast there as well. The temperature in the middle of this is colder than minus 40 or minus 35. It might be almost minus 40. And then you get quickly to 35, 30, 25 into the minus 20-ish range by the time you get down to Seattle, or Quilliu, actually. But that's a place where you've got a big cell of open cellular convection. The lapse rate's about 9 degrees per kilometer from the ground to 500 millibars. If it's moist, it's absolutely unstable. So interesting. The other interesting characteristic that you can see on this map is that this broadly zonal flow at a latitude that's the border of the US and Canada. And this is late October. So this is an unusually high latitude for that flow to be so strong and so zonal. And this thing is a sort of an escapee from the high latitudes, because that's a cold polar trough, and everything else is confined by this strong zonal jet at about the border. Now that helps to explain why it's so nice here and so warm. It doesn't quite feel summery, but it certainly doesn't feel like late October. And the reason is because late October is stored in Canada right now. And until and unless a fairly substantial wave activity starts to bring it down, we're not going to get that much colder than we are right now. So that's just how it is. And you can't escape the cool nights because you have 13 and a half hours of darkness. So there's nothing you can do about that. There's not any particular advection of high water vapor content to add that radiative element to the composition, because the water vapor is so good at re-radiating infrared. If you keep the air dry like it usually is in late October, it's going to get cold overnight. But it's also going to warm up pretty fast because it's sunny and we're protected from the really cold air. So this is a somewhat unusual map. I suppose if we looked at anomalies of the heights, it might really show up as anomalous. I haven't done that, but you can do that on your own. Let's go to 300 millibars just to accentuate the nature of the flow in terms of wind speed maxima. So here's a little bit of a subtropical jet. This is the underbelly of it, because the core of it's a little bit higher at maybe 200 millibars. But you can see the main jet structure over this part of the hemisphere is confined to the high latitudes of our country, the low latitudes of Canada. And that is insulation, as it were, against the invasion of Arctic air. Until and unless these things make their way southward, we don't taste that air. It's just the way it is, at all times of year. So, but this is quite unusual for right now. Now, one of the things that I've been not mentioning very much in this map, and this is the end of an interesting 36-hour period, 12th to the 28th of October. But really, would you expect, looking at this map and looking and imagining, remembering what the 500 millibar map looked like at the prior time, would you expect that over the last day and a half, there's been an exceptional anticyclonic development in that region? I would not. Okay, I mean, there's ridginess back here to the west over Minnesota. There's kind of the microscale ridginess here in the southern part of James Bay, maybe. And there's an intense jet streak around the base of this broad trough that's kind of fueling the cyclone we saw with the cloud streak going to Greenland. But this doesn't look like the ideal sort of broad scale setting for an intensifying, systematically intensifying anticyclone. So I was confused about this when I saw it show up in the forecast, and I was hoping that it would kind of verify as we got closer to the current day. And it did. So let's go to Alicia Bentley's maps, if we could, Pete. I think I've got it set at the right time. Yeah, this is 0Z on Thursday. Okay? So here's a 1020 millibar isobar. This is just after our rain went through and we kind of started to get a little bit cooler overnight, and a weak to moderate frontal passage was associated with the passage of this complex that's gone off to the east. But this is 1,020 millibars sitting over, the western part of our state, eastern Iowa, most of Illinois. Let's just click forward a time. I think we can do that with the buttons, mouse buttons. Yeah, so the next time, 1024, and you got 1028. Southern Michigan, just 6 hours later. So we've had an increase of at least 4 millibars in the central pressure, probably more like 5 or 6. Let's keep going. This is 1020, 1028. So this region enlarges, so the pressure keeps rising over the Lake Huron area, Michigan. Keep going. This is now 10, 24, 28, 32. Continued pressure rise at the center of this thing. One more. Now that's 1032, and we'll go one more after this, but because this is the last one. 1036, valid this morning over northern New York State, northern Vermont, and parts of southern Quebec. So we go from 1020 millibars, 0Z on Thursday, to 1036, 36 hours later. That's a remarkable anticyclogenesis event. And it's responsible for the beautiful weather across the whole eastern part of the United States now, today, because this is a sprawling anticyclone. But for the life of me, I don't really get how anticyclones develop. Isaac?
Is it odd to you that it seems to be right in the entrance region of that jet streak there as well?
Let's go back a couple of times and watch that jet streak. That thing gets stronger as this evolves. So it's not even there. Watch, go ahead, Pete. The first time you see the first light blue contour is right there. So that jet is intensifying simultaneously with the development of the anticyclone, which makes it even more mysterious. So I don't know how to bridge those two and make that connection. One of the things that distinguishes anti-cyclogenesis, of course, is, and I'll show you some things from a series of images I made to describe this. Of course, there has to be subsidence. One presumes that subsidence is the reason why the column gets heavier, because you're stuffing mass into it, and that will show up in subsidence. But when you do that, you make the stability in the lower troposphere larger, because the air is sinking and warming up. So you put the brakes on the very vertical motions that you need to fill the column with mass. Completely opposite of cyclones, where when the air is rising in the developing cyclone, there's latent heat release, which reduces the stratification and makes it easier for the same forcing to give you greater evacuation of mass. So the thing is a snowball effect. It's just the opposite with an anticyclone. So how in the world did you get 16 millibars of increased pressure here over 36 hours when it doesn't look like a very strong dynamical environment? Okay, so I spent this morning trying to think about that. I'll show you what I found about it. I guess we'll do that now, because that's what I wanted to do before I talk about the forecast. So I've got a PowerPoint on here, Pete, on my new Pete-powered computer. Yeah, this is the first image. So we can just blow this up on the big screen. This is the cold pool. It's unrelated to what we'll talk about in just a second, but look at what happened. Remember last week I told you, wow, we had this kind of dead period in 3 straight days of the warmest ever for those days by this measure, and then suddenly, boom. You know, if this is your stock portfolio, you're really happy, right? It's a nice recovery. And we're back to normal. And yet, when you integrate this all the way through from September 1 to the 27th, only up till yesterday, 27th of October, we're the 10th warmest year up to this point. And we've been kind of vacillating between like 14th warmest and 8th warmest or something. We're kind of settling in at around minus 10 from the top of the list. But that's a remarkable recovery for the cold pool. It doesn't suffer long losses like it had last week. Taylor.
So what would drive a rapid increase in the cold pool, like such as that? You know, you wouldn't have normal diurnal influences such as cooling at the poles.
Yeah, it's an excellent question. I mean, it's a broad bag of questions that to me are not obvious. And I've been thinking about this for years. Now, one thing that is tempting to say is that, well, you just, at a period when the cold pool was well below its calendar day average, you just had too much high amplitude flow that was advecting warm air poleward and kind of squeezing off these little pieces. Maybe some of them broke off and moderated, and so you end up with less than you usually have. But then how does it expand? My guess, and I'm not sure I'm right, my guess is that the flow gets less weight around the hemisphere, and then the cooling that is happening on this October 28th, like it has on every October 28th, back to when the dinosaurs were on the planet, is a function of radiative cooling and low sun angle the higher north you go. And so that's going to take over if the waves at lower latitudes don't stop mixing the air very much on you. So the radiation does the job that it's doing anyway, but it's going to do it and spread it out over a more even distribution. But that's just a guess. There's nothing non-radiative about this that I can tell. There's nothing non-radiative about it. But I don't know how the radiation and the flow in the atmosphere works together. It's a really interesting problem. So great question. But I've never seen, I think in the last several years I've been looking at this, that sort of a rapid increase to get back to normal. That's really amazing. Just 1 week has transpired. And even the last couple of days of that week seemed to be back to the flatlining. But there was a period of about 4 of those days where, boom, just went right back up. And you can see it on the daily maps, too. It's kind of interesting. Okay, so that's just for information. I like to give you an update on this every once in a while as we move into the winter season. Let's keep going on this PowerPoint, though, Pete. So here is sea level pressure. Every blue contour is going to be every 4 millibars starting at 1020. So here you see the 1020 isobar, and I just showed you that on Alicia's maps. This was for 0Z on Thursday. And if we can go to the next one, Pete, this is the 500 to 700 millibar average vorticity, geostrophic vorticity, in the column. And I'm only showing you, well, I could have shown you negatives, but there's hardly any negative absolute vorticity. This is the positive relative vorticity. So here's the feature aloft that's associated with the cyclone that was developing on Thursday and then made its way up into the Labrador Sea today. So that's the upper wave with that, and then this is tied to the baroclinicity and the cyclone that was further to the north and west, the one that came through us on Wednesday. So those two features are there. Now, if we put the thickness from 500 to 700 millibars on top here in red, you can see that there's all the way from, on the left-hand side of that axis, there's pretty good negative vorticity advection by the thermal wind right here in western New York State. And then another spot of it over the upper peninsula of Michigan and maybe the fingers of the hand in Michigan right in there. But it doesn't look particularly strong. Let me put the 600 millibar vertical motion, the subsidence on there. Look at that. Broad scale and very intense subsidence over northern Michigan, just downstream, down shear as it is, of the anticyclone position. So this is air that's broadly sinking, and it's widespread subsidence, and not really weak subsidence in the middle troposphere. 8 centimeters per second is pretty strong subsidence, approximately 8 centimeters per second. And it's really intense right where you have the strongest NVA by the thermal wind. So that's kind of cool. Let's go 12 hours ahead. 12 hours ahead, this is the 1020 isobar, this is 1024. So the area over which this high pressure exists is expanded greatly in these 12 hours. So let's do the same thing. We go to the next image. Here's the upper vorticity associated with the storm that'll end up in the Labrador Sea. We're kind of losing a little bit of the signal from the frontal feature that's farther north, but if we put the thickness on, we still have really strong NVA by the thermal wind in certain regions here in southern Quebec, and there's a little bit of it also here on the eastern shore of James Bay. And if I put the vertical motion on there at 600 millibars, look at that. Still 9, let's see, 5, 6, 7 centimeter per second downdrafts. And the expansiveness of where the air is sinking is really incredible. And the anticyclone is moving towards the subsidence, of course, and it's moving in the direction of the vertical shear, as it should. So there is a strong response, for some reason, to these seemingly weak pieces of the puzzle. And that's what's driving this anticyclogenesis. Let's go to the next time, Pete. So this is 1020, 1024, 1028. So this thing is not moving much, but it's just incredibly developing. We'll do the same thing again. Here's the vorticity. This is kind of now the frontal structure associated with the storm that is currently in the Labrador Sea. And then the thickness, unsurprisingly, it's tied along to that baroclinic zone, so we have a little bit weaker, but still negative NVA right in there by the thermal wind, and then the vertical motions are really, this is a double whammy, because we've got some NVA up here too, so this is broadening the area over which this mid-tropospheric subsidence is occurring, and it's just as strong, in fact stronger here, but it's just as strong as it was at any other time in this development. And it's downstream from the anticyclone. So of course, there's air being stuffed into this column and the anticyclone's moving in that direction. I think we have one more time, 12, maybe we don't. Yeah, 12Z, this is this morning, 1024, 8, 1032, look at that. 1032 millibars, centered over like Bennington, Burlington, Vermont. Let's see what it looks like. Strong vorticity tied with our cyclone now in the Labrador Sea. Here comes the thickness. This is the baroclinic zone of the cold front with that, so there's really strong NVA right here over the maritime Canada and Newfoundland, and then the vertical motions. 10 centimeter per second subsidence over that over the mouth of the St. Lawrence, and that's furthering the development of this. This anticyclone gets to a pressure of about 1035, right around this morning, or I guess after this morning, midday, 18Z. And so this thing is, look at the dominance that this feature has over the eastern United States, and it's the reason we have such beautiful weather here as well as all the way to the coast. But for seemingly innocuous ingredients in the middle troposphere, to have this thing develop at this rate and this intensity, really unbelievable. Okay? So I'm not saying this is the answer, but there's a few clues here about what's going on. I don't know why. One of the mysteries is, after this morning's look, one of the mysteries is why such a strong response in the vertical motion, and these are quasi-geostrophic vertical motions, to what looks like fairly weak forcing. And I've looked at these maps enough to know that it's kind of in the moderate to weak range. So there must be something about this, the stratification. Maybe the stratification's really weak, so a little bit of forcing goes a long way. And the atmosphere doesn't care if that's true. If you're able to force subsidence and create convergence aloft, in consequence of that, you're going to stop stuffing mass into the column, and the pressure just keeps on building. So this is a really intriguing case of anticyclogenesis. I think they're all intriguing, I should say. I came in, Libby heard with the little discussion I had yesterday about it. I don't think anybody can give you a quick, really comprehensive and well-understood discussion of how anticyclones really do work in terms of development. I mean, you can, clearly subsidence matters. Clearly you're stuffing mass into the column. But beyond that, what else can you say? I don't think it's been studied. You won't.
Could you go to top hole and look at the 300K mean?
I don't think I have that one up, Pete, so you don't think, go there. So what did you want to see?
300K TV, or it's not, yeah, 300K.
So that's in here, I think.
Yeah,
300 Kelvin, it's got,
TV.
well, we don't have that option. We have the wind, and so 330 is the best we can do on this.
Yeah.
So there's a 330 Kelvin PV right now. And so here's the positive PV at upper levels. That's the Texas event. And then broadly, it's weaker everywhere else. Here's the anticyclonic wave breaking that's kind of moved into the US. And our anticyclone is centered right here.
Yeah, but if you go back, there's a kind of TV streamer, small amplitude TV streamer that goes past, so there might be some subsidence related to that.
Let's keep going forward now. Don't go back anymore from there. So here's the region of interest, the things going like this, the anticyclone. So what do you see?
Maybe there's some subsidence.
This right here?
No, the one that goes already past the, our region of interest. Yeah.
This here? I don't know if it's a streamer, but I think you're right about this. There's one wave and a second wave, and there are regions of NVA on the backsides of both of those waves. And I think that might be one of the reasons why there's a broad region of subsidence. It's not just one feature that's controlling that. So to that extent, I think that you're right. I don't know if I see anything else beyond that, but you might see something else we could talk about. But it still doesn't look like, well, you know, you're going to look at this map and say, I guarantee you there'll be 16 millibars of pressure rise as this thing migrates across the eastern Great Lakes. I don't think you'd say that. It's just the way that the cookie crumbles in this case, but with mysteries to be revealed. I don't know what they are. So, okay. Thanks, Nuo, for pointing this out. It just, to me, it just adds to the mystery. This doesn't look like a strong case, but it is. So, okay, let's say a little bit about the forecast then. And to do that, we'll go to our, yes, I want to use Pete's maps. So let's start with 24 hours at the surface, Pete. So here's what we'll see tomorrow morning. This feature in Texas is, as we saw, it was kind of located at 500 millibars around the western part of the state, and it's not migrating very far in a whole day's worth of time, but it's precipitating over Louisiana, parts of Oklahoma, and Arkansas. And you can see that all of the other activity is confined to Canada. There's no other cyclone activity really going on over the continental U.S. except for that event right there. And that's, though anomalous, getting weaker as time moves on. It's not really getting any stronger. There's a really strong baroclinicity to this event that's in the Gulf of Alaska. Strong cold front, warm front, little bit of an occluded thermal ridge in there that you can see is coincident with the pressure trough, so that's a nice structure. And the precipitation forecast puts a lot of precip right along that ridge, and that's characteristic. And then the rest of it is along the warm edge of the cold front, and then some in the mountains is probably partly from the warm front, but then there's high terrain that has a big role to play there as well. But that's it. That's the cyclone that is the only other one besides the one in Texas. And let's take a look at what the upper level flow looks like at the same time.
Your anticyclone is still 1034 there?
Oh yeah, 1034. This is now a whole day from this morning, 1034, and stretched out. So a really amazing event. And look at how clear it is over this whole broad swath of the world as a consequence of that feature. And boy, that's a hard one to figure out. Okay, let's go to 500 millibars at the same time. And at 500, broadly speaking, Pete knows I don't like all these, the small splotches on these maps, but there's nothing you can do when you get high resolution data except smooth it 100 times. But there's our main upper trough that's now moved from western Texas to northeastern Texas. And then you can see again, the white lines are geopotential height lines. A series of waves. This is the one that's in association with the storm we just pointed out at sea level. There's a little feature kind of crossing the Canadian Rockies right about that time. But the main picture I see here is just broad zonal flow across the entire stretch from the Bering Sea all the way to the southern tip of Greenland without any waviness of any substantial magnitude across all of North America. And we, in the United States, are south of that strongest wind speed. So it's kind of a summary pattern for us. And here's one of those regions, Grant, of the anticyclonic wave break, prior anticyclonic wave break. There's a big anticyclone there aloft. And not surprisingly, our surface anticyclone, as Pete pointed out, is right in this region. Okay, let's see what it looks like at 850. So there's the big cyclone that's tied to the wave we just talked about. Even at 850 millibars, one sees pretty much a zonal flow in southern Canada, and not much flow of any magnitude at all across the continental U.S. Here's the anticyclone's presence at 850 millibars. And it's right through the heart of it is a decent baroclinic zone from its eastern edges to the center of it, and then after that it's kind of an amorphous temperature structure to the west of the anticyclone. And we're not particularly cold, but we're not particularly warm. The flow across high terrain occasionally induces these lee-side geopotential height troughs, and it's coincident this time with a warm bubble. This is at a fairly unusual location for one, but there's high terrain in western South Dakota, and then there's high terrain right in here, and so they can maybe conspire to produce that fairly weak warm anomaly, which I don't think lasts. And I'll let you look through the maps one at a time to see what you find, but I think that's what I saw this morning. So I want to see if anything develops out of this whole fairly energetic complex. Look at how cold this area is coming off of the continent and then coming southward across the Bering Sea. That's really, really cold, very sharp cold front. And we saw that evidence of that, another prior event with the open cellular convection that will show up there again tomorrow morning, it looks like. So let's go back to 500 millibars and we'll page through a few of these, maybe at 12-hour intervals. We'll go to 36 hours. Whoa, I don't even know what's happening there. I feel like I'm at that Van Gogh exhibit.
Need a shirt like that.
Yeah. So look at these waves. There's just one, two. It's almost like a beautiful idealized model simulation across high terrain. Somehow they still keep this integrity. I think that broadly there's going to be an intensification because of upstream features that you can look at yourself of the waviness here. And so there'll be a digging of this trough, and that's going to set us up for the late part of the weekend and the early part of next week. When I mean the early part of next week, I should say. We're already near the late part of the weekend. Let's go 12 hours ahead and see what that looks like. 12Z Sunday. Still, the broad picture is the strong flow at 500 millibars is north of the border, very little flow south of the border. Doesn't look like late October, but it's very energetic at higher latitude. There's a wave coming across southern Hudson Bay, and here's the one that's kind of probably occluded up there on the Gulf Coast. But notice the ridginess that's building over the Bering Sea. Let's go 12 hours further ahead, Pete. And I'd say it's broadly the same thing. The strong zonal flow is at the border. This wave is kind of developing a little bit more as it goes across eastern Hudson Bay. And look at the ridginess in the Bering Sea that makes most of this flow northerly. And so we've got a fairly strong northerly flow across western Alaska into the Gulf of Alaska, then into the British Columbia coast, digging out this trough. Maybe we'll go to 300 millibars at this time. This is a 60-hour forecast, just to see what the winds look like there, because that can be a useful thing to see. Oh, I'm surprised. Okay, I thought the jet was going to be stronger on the western side than the eastern side. Strong zonal jet, though, just as we could have intuited from just the 500 millibar map. And keep in mind where we are with this jet streak north of the border with Canada. Incredible. And nothing particularly strong in the northwesterly flow. I was wrong, I thought it would be. Okay,
It's kind of
let's,
like a smirk, like a face.
yeah,
It's like Halloween.
Yeah.
2 eyes, there's the mouth,
yeah, sort of the Joker or something,
kind of
yeah.
a Melissa thing.
Let's go to 72 hours at 500 milliamps, see what we see there. Okay, same broad picture, although I think things start to get a little more northerly here over western Alaska. And we'll go 12 hours further ahead than this, and then we'll go to 300 after that now. Not yet, not yet. Let's go to 84 hours at 500. Thanks. Okay, so here's a strong northerly flow with a vortex strip, probably an upper front. I'm gonna guess the jet has gotten a little more intense on the western side of this upper trough that's beginning to develop. When that happens, you know, you have a jet exit region in about this region, in this location, and the air is rising in the left jet exit region, cools it off, lowers the heights, trough digs. Let's see what the 300 millibars looks like at this time. Yeah, starting to look more interesting. 154 knots, strong jet streak in the northerly flow on the western side of this trough. And so the heights are falling here, and that's just gonna drag that troughiness off the coast, deepen the trough itself, and that will start to set up a change in the flow. Because still, we're seeing from this longitude eastward, pretty much a zonal flow with a little bit of an inflection in the eastern part of North America, but broadly speaking, not much going on across the continent. And there's a little example of one of these, yet another anticyclonic feature invading over us. So let's go to 96 hours at 500 millibars. That'll get us to mid-morning, right, or morning on Tuesday, 12Z Tuesday, yeah. And so I think you'd agree the complexion of the flow has begun to change in a substantial way. This is maybe the axis of the strongest flow at 500 millibars. All through this discussion up till now, it was oriented zonally. And now it's clearly oriented from southwest to northeast as this trough continues to dig out over the Pacific Northwest and offshore of the United States. So let's go to 300 again, Pete, at this time. And so look at that. Now that jet streak, we had a grimace before that Pete was talking about. Now it's from southeast or southwest to northeast. And this is still the stronger of the two wind speed maxima. So this trough is going to continue to dig most likely, probably dragging that further south. And what that's going to do, of course, is change the orientation of the flow on the eastern side of it. And it becomes more and more and more southwesterly. And not just at upper levels. Let's go 12 hours ahead here to Tuesday night. First, we'll look at it at 300 millibars.
Oh, sorry.
Because they're really showing the same thing. So. Yeah, so now we're getting a really deeper trough along the coast itself, and then a big southwesterly, southerly almost flow over Nevada and Idaho, but southwesterly over the Intermountain West, and broad ridginess over the central part of the continent. What does it look like at 850 at this time? So this is a 108-hour forecast.
Oops, sorry.
And son of a gun, a really intense warm bubble, coincident with a geopotential height trough. This is the lee side trough. The flow is, remember, like this, and then coming across the high terrain, which is oriented like this, and downstream of that, at the place where the strongest across mountain flow is, you get the warmest air. And this is very warm. This is like plus 20 degrees C in western Nebraska and southwestern South Dakota on Tuesday night. This isn't even the daytime. So let's go to 18Z on Tuesday if we could, Pete. That'll be 126-hour forecast. So this is midday on Tuesday, and there's a lot of warm air flooding across the Central Plains into the Dakotas, into northern Minnesota. Look at International Falls, it'll be like plus 16 at 850. And then later on in the week, you can see what's happening. Here's a strong baroclinic zone that more or less defines the eastern edge of the trophy region. And then there's warm air ahead of it. There's a cyclone brewing in the geopotential heights in eastern Montana, and that's inducing strong southerly flow. Let's go.
This is actually Wednesday, not Tuesday.
Oh, I meant to say Wednesday, yeah, it's midday Wednesday. So let's go to 12Z Thursday, which would be 18 hours from there, so 144, is it, I think? Yeah, this is 12Z Thursday. Cyclone has moved slightly eastward, but look at what it's placed us in. Really strong warm air advection region at 850. This warm air has not disappeared over this whole time. Here's evidence at 850, the cold air, of a deep trough that's carved itself out over the southwestern United States. Strong baroclinicity is the only thing guarding us from this bloody cold air, minus 26 at 850. We're gonna have a very warm, progressively warmer week as we go from Tuesday to Wednesday into Thursday. But of course, late in the day, Thursday, let's go to 0Z on Friday, so 12 hours ahead. Then we have to contend with the approaching frontal passage. It's not really tied to a strong cyclone, but it doesn't have to be when it's this strong of a frontal passage. It's going to cool down eventually, probably not by the end of the day, Thursday, but into Friday, it'll cool down and it'll really get cooler fast. 20 degrees or so Fahrenheit temperature drop in a few hours when this thing finally comes through. So this will be not unlike what I think Monday felt like, where it was increasingly high cloudiness and stuff like that, but still really warm with brisk winds and not as high as 72 degrees, I don't think. I think we'll probably be in the mid 60s, if not low 60s. But you can see this might be the last gasp, because it is really cold over the continent now, and there's not a lot that's going to keep this cold air from finally making its way, settling southward over us. So the coming week might be the last one where you kind of enjoy taking a walk after work or whatever it is that you might do on these days. Good weekend to get rid of leaves off your trees. There'll be windy conditions during the week that's coming that will bring even more of the leaves down without much precipitation. That makes it easier to move them around. And then pretty nice days to rake up the rest of them. So we're really being gifted with a fairly nice fall up to this point. And we'll certainly, when we reconvene next Friday, we may be reconvening for the last warm afternoon of the year. So that's what it looks like to me. But the big picture is a really broad change in the nature of the flow that we're enjoying now. Zonal flow north of the border turns into one with a giant cutout upper trough to our south and west, which makes us warm, but not forever, because when the whole thing progresses, the cold air follows, and you can't escape. Okay? So that's all I have for today. So Pete, thanks for driving. Thanks for helping me with my new machine, which of course performed brilliantly. And thank you all for your attention. I'll see you next week.